So once we know this is G prime, which isn't a surprise because it says graph of G prime right there, okay, then we know on this interval what's G doing. G prime is increasing, but G is decreasing. Okay, that's what that means. G prime is negative, so G is decreasing. And then we have and how much does it decrease is our new rule. How much it decreases is the area between that line and the axis. And to give you a question like this, it'll always be a shape that you should be able to find the area of. That's a triangle. Okay, and the area of a triangle is a half base height. So this has a base of 1, 2, 3, 4, 5, and a height of 1. Right, -1 really, technically, okay? So the area in there should be 5 halves. Is that okay? Did I mess that up? That's right, right? Yes. Cool. But since it's below the axis, we're going to put -5 halves because it represents a decrease of that much. Okay? So in this area right here, I'm going to write it up here since that triangle is kind of small. This area is -5 halves. All that means is from -7 to -2, G decreases by -2.5. Cool? So whatever it was at -7, now I can find out what it is at -2. I don't know what it was, but I'm going to find out eventually. Okay? Then we know we got a semicircle there. The area of a semicircle is 1/2 pi r squared. Right? What's wrong with that? I did. Yeah, I got like a nervous twitch here. Okay? No, but it's 1/2 pi r squared. R is 2. So that should be 4 pi. So the area in each of these semicircles here is pi. Or it's quarter circles, I guess. It's really 2 pi, right? But pi in each one. If I mess up, please let me know. Okay? Y'all with me? Just find areas. The area of that other triangle, which indicates an increase as well. Cool. And actually, because they're going to ask me specifically what G of 3 is, I might just split this in half just to make this a little bit easier for myself. Okay? The area in that first part is 1 times 3 times a half. That's 3 halves. And the area in the second part is, it's kind of hard to tell where this hits. We could find the equation of that line, but a lot of times with these questions where they give you a graph, they're not messing with you too much. Okay, this happens to be exactly 4.5. All right, so the base here is 1.5, or 3 halves, times 3 is 9 halves, and we're dividing that by 2. Cool, so again, the formula I'm using there is 1/2 times the base, which is 3 halves, times the height, which is 3. And that's 9/4 in there. And you can use some decimals there if you want. I think fractions are a little bit easier. And then we've got this little tiny negative triangle here. You can see they're messing with you with some fractions. That's got a base of 1/2 and a height of -1. So you would do 1/2 times -1 times 1/2, and that's -1/4. That's the area in that little tiny triangle. Right there. Everybody handle that? So all this graph tells us, and once you put it in these terms, it makes these questions a whole lot easier, okay? It says, whatever G is at -7, it goes down 5 halves, up 2 pi, up 3 halves, up 9/4, down 1/4. Cool? So once I know one point on this graph, I can find out where G is everywhere, because I know how much it's going up and down. All right? And they happen to tell me that right here. So you're going to find, too, I know a lot of times you just want to skip this paragraph they put in front of here, but you should really read everything they're telling you. Like, they don't ever put any like extraneous information in here. Okay? They always put something that's useful in here. Like, they tell you about concavity sometimes. They tell you like little bits of information. So make sure you read that whole prompt and make sure you take note of everything they tell you. Because sometimes one little piece of information is the key to answering the whole question. By the way, we know G of 0 is 5. Cool? So how do I find G of 3? Well, if I know G of 0 is 5, that means G of 3 has to be, I'm starting at 0 because that's where I know G. If they told me G of -2 was 5, I'd start at -2. Okay? But I know G of 0 is 5. By the time I get to 2, how much has G gone up? Pi. But it was 5. So now it's going to be 5 plus pi. That make sense? So G of 3 has to be 5 plus pi plus 3 halves. And that gets me to 3. Cool? And you just got to put that together. And that is 13 halves plus pi. That's G of 3. Everybody okay? Feeling good. Now, all they really did there, by the way, and the way they're going to write their answer out, is they're going to use all this math notation. They're going to say G of 3, and we'll get in this a little bit later too, is 5 because we know it's 5 at 0, right? So we start at 5, and we're adding the integral from 0 to 3 of g prime. That's the way they write that. Remember we said this integral represents two things. A change in the antiderivative, which is g in this case, or the area under g prime to the x-axis. Cool? And that's what we found. We found the area. So it's just 5 plus that area, and that's why it's 13/2 plus pi. I mean, in sense? A lot of times these questions really just boil down to some geometry. You find the areas and you add them together or subtract them off, depending. Cool? Now, g of -2 is a little bit trickier, so I'm going to do this down here. So A. It's not really super tricky, but we're going backwards, though, is a problem. So look, to get to -2, here's what I know. From -2 to 0, g had to go up pi, right? It went up pi. But at g of 0 is 5. Okay, so it ends at 5. It goes all the way up to 5, so we got to figure out where did it start. 5 minus pi, right? It had to, right? Now they put a pi in there to make it look more complicated. But g of -2 has to be 5 minus pi. Because if g of -2 is 5 minus pi, then when you go to 0 like this, you add pi to that and you get 5, which is what you're supposed to get. So general rule is, if you're finding area like this, if you're going forward, you either add or subtract if it's positive or negative, right? You follow the rule. But if you're going backwards, you do the opposite of what it says to do. Because you're going like downhill sort of. Okay? Because if it increases from left to right, then from right to left it has to decrease. Okay? So going right to left, you do what the area says. Going left to right, you do what the area says. Right to left, you do the opposite of what it says. Cool. So like if they ask me what's g of -7, I would subtract pi and then add 5/2. Cool? All right. So that's how you do A. And that was the real question that I want you guys to answer. That I hope some people, that makes sense and we were able to get there. How about B? B says we want to find points of inflection. So the AP exam is really good at asking questions in like a different way than you've seen before. You know how to find points of inflection. We find what? Where the second derivative, not specifically where it's 0, but where it changes sign. Okay, it has to change sign. Cool. So that's what we're looking for. Where does the second derivative change sign? And if you're confused about the question, write out what you know and try to piece together what rule I know and how can I get it from this. I need g double prime to change sign. That's how we find points of inflection. Whether they give you a graph or a function or anything, but that's our rule for points of inflection. Okay? Now we don't have g double prime. We have g prime. Cool. However, from g prime we can look at this. I'm going to erase all these areas for a second. I'm going to be annoyed by that later on, but let's erase all these areas. What's g double prime on this interval? Positive or negative? A lot uncertainty. Okay, it's positive. It's positive. Because g double prime is the slope of this graph. Okay? So if they give you g prime, which they do a lot of times, they'll give you g prime, and they'll say, where are the points of inflection of g? Well, basically you just need g, or g prime, I guess, to go up then down, or down then up. You need the second derivative to change sign. So look, the second derivative is positive here, and then it's positive here, we're still going up, and then all of a sudden, oh my god, it's negative. Guess what happens at 0? A point of inflection. And when they say explain your reasoning, you just say the rule that we know. There's a point of inflection there because what did g double prime do? It changed sign. Okay? That's all I got to say. There's a point of inflection at x equals 0 on g because g double prime has changed sign. You could also say, same reasoning, that g prime has changed from increasing to decreasing. Okay? That's the same exact rule, just like a different way to look at it. And then look, g double prime is negative until 2, and then it's positive. So guess what's happening at 2? Point of inflection, because g double prime is changing sign. Okay? And then at 3, we change direction again, which means g double prime has to change sign again. Cool? So there's 3 points of inflection. One at 0, one at 2, and one at 3. All right? And you can write it just like that. And look, that didn't require us to do any, it's weird because when we start doing this in class, you got to do the second derivative all the way down, do all this algebra and all this crap. It's really annoying. But when they ask you on here, they just want to know, do you know this rule? They're not even testing your algebra skills. Like, do you know how to find points of inflection where the second derivative changes sign? Okay? So, and that's all it says. Find each x coordinate at the point of inflection and explain your reasoning. So, you can write this out however you want, but there are, not however you want, but there are points of inflection. And now, we don't know the y values, and it doesn't matter. We can find them if we needed to, but it doesn't matter. At x equals 0, x equals, I forget already, 2, and x equals 3. Cool? And then explain your reasoning. Just say the rule that you're using. Because g double prime of x changes sign. I have the worst handwriting. Changes sign at those x values. Okay? Look, see a lot of people not writing things down. That's very good. Relax. I hope you're having a good time. We are going to have quiz questions like this, and we're going to have test questions like this. So, I'm just saying, as a student, writing things down is helpful. Okay? That's it. And look, if we scroll over to their answer key, which is right here, boom, they're specifically saying, look, at 0, 2, and 3, because g prime changes from increasing to decreasing. But if you say that, like, you can't say changes direction. All right? You got to say specifically it's changing from increasing to decreasing. We're talking about g prime now at 0 and 3, right? And it changes from decreasing to increasing at 2. Or you can just say the second derivative is changing sign at those values. That's the same exact reasoning. Cool? And look at the points here. For A, like, so every one of these questions is worth 9 points. A was worth 3 points. If you use g of 0 equals 5 at all, you get a point. So in the AP exam, please don't leave it blank. Like, if you know anything about the question whatsoever, put something down, right? There's lots of partial credit to be had on here. Cool? G of 0 is 5. If you just use that in adding, even if you add wrong, you're still going to get a point out of 3. Okay? And for B, even if you can't explain it, if you can find them, you get half credit for that question. Okay? Now C is a pretty big pain in the butt. So let's go back. And you're going to find this with free response questions in general. A lot of times A and B are hopefully relatively simple. They're kinds of questions that we've seen in class. They're questions that we're going to do a lot. But these people that write this test are really good when they make up parts like D or C, the last part usually. Not all the time, but they ask a weird question in a weird way. And you're like, what the hell just happened? Like, we've never seen anything like this before. And they do it every year to me. I try to prepare the kids as well as I can. And every year I look at the questions, I'm like, my God, that is just a random question. Like, where did it come from? They're still using calculus rules, but it's just like weird. They ask it in a weird way, and it's hard to predict what it's going to be on some of these. So don't walk into this test when you're taking it expecting to get 100%. You're not going to. All right? Like, I read a news article last year that was like all about one kid that got this 100% on it. Like, such a few students, like small fraction of students, get 100% on this thing. You don't need that. You need like a 70%. That's it. 70% to 5. Okay? That's what we're shooting for. So on these free response questions, if you can get 2 or 3 of the parts, if there's like 4 parts, then you're doing pretty good. Okay? Now, in the class, I'm grading you on the whole thing, though. So, but the AP exam, you just need a 70%. Okay? Okay, I'm evil. I know. I get it. All right, so now they're making up a new function, h. H is now g minus something. And this is something that they do like to do, like take something they've given you and twist it up a little bit. Okay? We want the x-coordinate of the critical points of h. Okay? And we want to classify the critical points as local mins, maxes, or neither. So, it's a weird way they ask it. It's a kind of different way, but we know how to find critical points. That's where what happens? First derivative is 0 or undefined, right? 0 or undefined. As long as there's points on the original function. Okay, that's a key thing for us. So all we need to do is find out where h prime is 0 or undefined. And even if you can't explain if they're maxes or mins, if you can find them, you're going to get partial credit. Okay? Remember, we're thinking college credit here. All right? So I'm going to do it over here. For part C, we want to find the critical points, so we're going to derive h and find out where it's 0 and see if it's ever undefined. Spoiler alert, it's not going to be undefined anymore. That's fine. Okay? So h prime of x is equal to, well, how do I derive g? So that's something kids are always like, well, I don't know what g is. How do I derive it? What's the derivative of g? G prime. Yeah, that's all you say. It's g prime. We have a graph for it. We don't have to know what equation it is. We have a stupid graph. Okay? And that's minus x. And we need to know where does that equal 0. All right? Which is a tricky question. We solve questions like this. If we have algebraic formulas for these things. We factor, right? We get everything on one side, we factor, and we see what makes it 0. We don't have a formula for G prime, though. We have a stupid graph. How do I tell solutions from graphs? What do I look for? Where things what? This is the same thing, think about this, as that.
Your attention, please.
Oh.
The PA system at Long Reach High. Thank you.
Glad. That would be a terrible job for me. I'll just say something inappropriate, I think. Okay. How do we solve equations if we have graphs? What do we look for? Not 0. Well, so yeah, if we want to know where this equals 0, right? But we don't have a graph of G prime of x minus x. We just have a graph of G prime, right? So that's why I'm isolating G prime. I want to know where it equals x. That's going to happen when those graphs intersect each other. That's how you solve graphically. And that's an important thing for us to remember. Okay? AP exam gives you tables, they give you graphs, they give you functions. Okay? You find out where things are, when two equations are equal, where they intersect. So all I got to do is go back up to G prime and graph y equals x. I want to know, where does G prime equal y equals x? Well, you know what y equals x looks like, right? It goes through 0, 0, it goes through 1, 1, it goes through 2, 2, it goes through 3, 3. How many intersection points are there? There's 2 of them. There's one here, which we got to find, and there's one here. What's one critical point? 3. We got 1. Okay? Now, finding the other one requires us to know the equation of a semicircle, which we've been over. Okay? But history tells me that you probably don't know the equation of a semicircle. Okay? So put this down somewhere, like they expect you to know this. The equation of a semicircle is always, from pre-calc, if it's centered at the origin, it's just y equals the square root of the radius squared minus x squared. Okay? Something that looks a little more familiar, though, so that's one way to write that out. Another way is, remember this from last year in pre-calc? X squared plus y squared equals r squared. That's the same equation, just solve for y. What do I want to know about this? So solving for y makes it easier. What do I want to know about this? Where it what? Where it equals? Not 0. No, we don't want to know where it equals 0. We see where it equals 0 right here. This is, look, equals 0, 2, and negative 2. We know that. We want to know where it equals x. I want to know where it hits x. Does that make sense? That's a system of equations. We can solve that one of 2 ways. All right? Well, graphically is one, which we can see the answers right here. You could take a guess and try to figure that out. All right? A little bit tough. Actually, let me show you several ways to do this. Just real quick, because you guys know this information. I know you do. All right? What angle is here? If this is y equals x, what angle has to be there? A 45-degree angle. What's the radius from here to here? 2. Right? This is a triangle. If it's a 45, 45, 90, and the hypotenuse is 2, what do the legs have to be? How do you go from hypotenuse to a leg? Do you remember this? You divide by root 2. That has to do with all the trig, the special right triangles. 2 divided by root 2 is root 2. That's that x value we're looking for. It's root 2. If you don't know that, you could take the equation of the semicircle and set it equal to x and solve that. You're going to get root 2. Okay? If you don't like that, you could take the equation of the circle right here and do a substitution. What's y have to equal? What are we looking for? Y has to equal x. Great. Plug an x in there for y. Solve that equation. Every single one of those ways is going to tell you x is root 2. Okay? And that's the first part of that answer. X equals root 2 and x equals 3. Okay? And then the question is, tell me if it's a max or a min and explain your reasoning. So we'll go over this. This is a little bit tough as well. We've got this line here, right? It goes through there, boom, something sloppy like that. Okay? Remember, we're saying that the derivative of this h function we're talking about was g prime minus x. Well, how do I tell if it's a max or min from our derivative? What do we do? We can do 2 things. We talked about this. You could check concavity, which is the second derivative, or you could tell if the first derivative changes from positive to negative or negative to positive. Okay? Well, it turns out that since it's g prime minus x, let's just go through. Look, g prime is the graph we're looking at. X is this red line. Before I get to this point, what's bigger, g prime or x? G prime is bigger, so g prime minus x must be positive. Cool? So let's make our number line. We got our points, right? There's a point at root 2, there's a point at 3. Before I get to root 2, it's positive, because g prime is above the line. After I go past root 2, g prime is below the line. So now g prime minus x is negative. Okay? As I approach 3, g prime is below it. So g prime minus x is negative. And on the other side of 3, g prime is still below it. So it's still negative. What's root 2? A maximum. And 3 is? 3 is neither. It has to, the sign has to change sign. Yeah. The derivative has to change sign. Cool? So you're going to write, look, it says find them and classify them and explain. Cool? So you'd write critical values at x equals root 2 and x equals 3, right? X equals, now you got to write a little bit here, okay? Like your number line is not explanation ever. You can use your number line, it's not wrong to do it, but it's never your explanation, okay? X equals root 2 is a max. And you say that because, don't say it, all right? Don't say the derivative, name the function we're talking about. H prime of x. We're talking about the derivative of h. Because h prime of x changes from positive to negative at x equals root 2. Cool? Then you write the same thing for root 3, but, I'm sorry, 3, but it's not changing sign at 3, so you're going to say neither. X equals 3 is not a max or a min, since h prime of x does not change sign.